All right, we're going to take a look at our practice test for that EOC. So what I want you to type into Google is algebra EOC practice test Georgia. So if it doesn't come up for you, you can go ahead and type it all out. Georgia. All right. Algebra EOC practice test Georgia. And the very first one where it says welcome to experience online testing, that's what I want you to click. On this page, I want you to click test practice guides and samplers. Then I want you to do online tools training, end of course. So again, click on this first one. Then I want you to click on test practice, first top left. Then standard online tools. Then algebra 1, concepts and connections. Then hit continue, practice tests. Then you're going to press the arrow 5 times to get to the test. 1, 2, 3, 4, 5. Then we're going to begin the test. All right, so these are going to be our test questions. I'm just going to go over them so that you have the answers and you're checking your work. So look at the quadratic function below. This is what we have. What is the equivalent form, which means this matches this. So as soon as I hear what is the equivalent form, I'm going to go ahead and type it in. Just to make this a little shorter, I'm not going to type in f of x just to save time. So whichever one matches this perfectly is our answer. So I'll start by typing the first one. Does that match? It does not, so that's not it. I'm going to mimic this one. So it's x minus 4 squared, and instead of plus 15, it's minus 1. Oop, that's the one. It matches perfectly. This is an equivalent form. And I just want to tell you, again, let me just really quickly tell you the differences here. So if we go to our formula sheet, we have quadratic functions. We have 3 forms. We have standard form, which is this one. We have vertex form, which has 1 parentheses, and you can see that's 1 parenthesis squared. And then we have factored form, which is 2 parentheses. So sometimes they'll specifically ask you to go from standard to vertex or standard to factored or factored backwards. You just need to know what the forms are, but you can get that right out of the formula sheet. All right, for question 2, what function can be used to model this data? Hey, as soon as you see a table, what do I want you to do? Put it in. All right, so let's go ahead and top left plus sign, table. Let's copy in the values as you see them. Double check them to make sure that you copied correctly. Don't want you to get it wrong for no reason. And we can see that this is a function. So how do I make this a function? First, I'm going to zoom fit. I can see that what kind of function does it look like? It looks like linear, which makes sense because all these answers are linear. So I'm going to click flag and leave it on linear. If it was anything else, I would change it. But right now, I know that it's linear. I'm going to make sure that it perfectly goes through each point. That's why I hit zoom fit before I put in this answer. So this is my answer. I have a fraction, so I'm going to copy this in here real quick. I have 0.5, which is going to become, if I hit the fraction, 1/2. So my answer is 1 divided by 2. And I'm going to make sure it matches, and that's what I pick. And that is the same as saying x divided by 2. But we're not going to even trust that. We're going to actually write it that way. So we're going to see if it works if we write it exactly as the answer. Yes, it does. So that answer is B. What statement explains why this is rational? All right, so I need definitions for rational. So SQRT, let me say 2. An irrational number does not terminate, which means it keeps going on forever, right? And even though this looks like it stops, it doesn't really stop. At some point, Desmond has to stop writing the numbers, which it chooses to stop writing it after, I think this is 9 or 10. All right, so irrational does not terminate, doesn't stop. Does not repeat. So let's look if we see any repetition. So 4, 1, 4, 2. Okay, that doesn't work. 4, 1, 4. Nope, that doesn't work. So this is not repeating. So irrational does not terminate, does not repeat, and cannot be written as a fraction of integers. You see right here? There's no fraction bar. I can't write this as a fraction of integers. However, if you have a rational number, so let me think of a rational number real quick. SQRT, let me do 9. If I have a rational number, it terminates. You see how it's just 3. It doesn't go 3, 3, 3, 3, 3, 3, or 3, 5, 8, 6, 9, 10, or whatever. It does not go on forever. It could repeat. In this case, it doesn't need to repeat. Or you could look at 3.0000000 is repeating. That's the same as 3. And it can be written as a fraction. You can write 3 over 1 as a fraction. You can see it's 3. All right, let me give you a different one. Let's give you 0. This one is the one you guys get a lot. All right, 0.666666. All right, is this rational or irrational? It's rational. Why? Because, and let's just say this keeps going on forever, okay? It's rational because the 6 is repeating. And look, I can also write it as a fraction of integers. Now, I just want to go ahead and teach this here too. Does that look right? Absolutely not. Now, this is the end of the year, so you should know this by now. You keep going till it goes away and then it comes back. You just hold it down. So you can see 2 over 3 is a fraction, a ratio of integers, which makes this rational. All right, so now that we got our definitions, let's look through the question. Which statement explains why this, add in these two, is irrational? So both radical 5 and 4 over 3 are irrational. Let's take a look at that. SQRT 5. Is that irrational? Does it, three things, go on forever? Yes. Does it not repeat? Yes. Can it be written as a fraction? No. So this is irrational. All right, let's look at 4 over 7. 4 over 7 can be written as a fraction because it was a fraction anyway. So this one is rational. This one is irrational. Now you see this 4 over 7 one, right? It actually has a repeating, and I love that they've used this example because the one you guys are used to seeing is this one, which, you know, is obvious. It's just repeating 6. But it doesn't have to just repeat the number 6. It can repeat a sequence of numbers. So let's find what's repeating. 5, 7, 1, 4, 2, 8. That's what's repeating. 5, 7, 1, 4, 2. And they rounded because Desmos didn't want to go ahead and say 5, 7, 1, 4, 2, 8, like forever. So it rounded this last number because that 5 brings it up. So it doesn't have to repeat just one digit. It's just a repeating pattern. So this is rational. All right, so both of them are irrational. Nope. Both of them are rational. Nope. One is irrational, which is radical 5. Yes. And then this one is rational. Yes. This one is rational. No. So this is the only answer even without reading the explanation, but the explanation says the sum of an irrational number and a rational number is always irrational. Now you don't ever have to remember this because all you have to do whenever you're doing explanations is type in whatever they're saying. So if it says the sum of an irrational, which is this one, and a rational, which is this one, I would just go ahead and add those two together to see, is this rational or irrational? And I can see there's nothing repeating. It doesn't end, and I can't write as a fraction, so it's irrational. So I never actually remember the rules. To look for the rules, you just type it in here and you look. Make yourself an irrational number and a rational number and then see if it's true. All right, so that answer is C. Question number 4, look at the quadratic below. What are the solutions? All right, there are 4 words for solutions. Again, see if you can say them before I do. It is solutions, roots, x-intercepts, and what am I missing? Solution, roots, x-intercepts. I'm missing one because I can't think of it right now. Zeros. Oh my gosh, I can't believe I forgot. So solutions, roots, x-intercepts, and zeros. All right, so those are the four words they could use to ask the same question. So if they're asking me for my roots, I know that I'm looking for my x-intercepts. So I'm just going to go ahead and type it in. All right, so this is my equation. Here are my x-intercepts. Boom. Now, this does not look like this, but what can I do with this so that it looks like this? Just type it right up in the calculator. So I have -3, and then how do I handle plus or minus? Because it's 2 separate equations. This says -3 plus radical 2, which is what I'm going to do, SQRT 2, and then the same thing, so I'm going to copy, all right, minus. So it's plus or minus. It's 2 separate equations. All right, so these are my solutions. I'm going to click on my solutions again. Does this match? Be very careful. -1.5857, and then they round. Yes. -4.4142, and then they round. Yes. So this answer is A. I'm just going to show you one more just to make sure. So let's do -6 plus or minus. So that's an easy change. I can do that real quick. All right, and then again, I click on it. So one of the, actually none of them, none of these match. And if you go through the rest, you're going to see they don't match. So A would be my answer on this question. All right, we're going to go to number 5. A squirrel population in a forest has grown at a constant % rate. The table shows the number of squirrels in the forest over a 3-year period. What is the constant % rate of change of the squirrel population? All right, let's go ahead. I see a table. I have no idea what they're talking about, right? I put in a table. I type in what they have in here, and I be careful to make sure that I check my table after I'm done. So this is 1,000. 1100, 12, 10, 13, 31. Double check your table. Now, I don't know what this is. I see percent in the question, so I know this is exponential, but let's assume I don't know. Hey, let's go ahead and zoom fit that, and let's look at what it looks like. And I think I just made a mistake because I added a 3 here by mistake. All right, so this is what it looks like, zoom fit. All right, so it looks like it could be linear, to be honest. So at this point, you would have to know that it's exponential. But let's put our line of regression. Does it go perfectly through this? No. So actually, it's not linear. And this is not a scatter plot. So it would be different if we talked about this as a scatter plot. So it has to perfectly fit. Let's go ahead and try quadratic. All right, quadratic looks like it fits, but remember, sometimes you just have to zoom, 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 zoom in on a point. Does it fit quadratic? Absolutely not. So the one that it has to be is exponential. Does it perfectly fit exponential? It does. Zoom fit to bring it back. All right, so now that I've proved that it's exponential, I can answer whatever question they have. What is the constant percent rate of change? All right, now exponential from our formula looks like exponential midpoint, exponential a, b, and x, and you have to know what each of these things is. So a is my initial amount, b is my factor, okay, so how I'm going to be growing if it's going up, or decaying if it's going down, and x is my time. And then while I'm here, all right, inside of b, if you have b written as like 1 plus 0.02 or something like that, this is called my percent rate. So this whole thing, which is 1.02, is called my factor. And because it's bigger than 1, it's growth. Between 0 and 1 is decay. All right, so now that I know all my definitions, I need to find how it's changing, right? Which is this 1.1. So my factor, okay, not my percent, my factor is 1.1. So my factor is 1.1, which means they have combined, which I know is growth. So they did 1 plus something to get 1.1. And obviously that's 0.1. But remember, growth is easy because you can see it. There's a shortcut for this that we do. And we always put it in absolute value or ignore the negative, whichever way you want to do it. And we go 1 minus whatever the factor is, which is 1.1, and then times 100. So times 100. Okay, that will always give us our percent. All right, so with growth, it's easy to see that it's growing by 10%. But if it's decay, please, please, please do not forget our shortcut formula. All right, so if I give you the factor, which is the whole thing in the parentheses, or I give you the percent rate, which remember this has been divided by 100, you need to be able to go between both of them. So you need to know the definition. So please practice this question to make sure that you understand how to make it back into a percent rate. All right, question number 5, number 6. Which scatter plot? Okay, so we are on a scatter plot. Stores the strongest. Now strongest. So with scatter plots, remember it goes from, and I don't know how to write this in here. So let's say, I'm going to just put spaces. -1 to 0, then +1. It is never outside. Strength correlation coefficients are never less than -1, so it can be -1.1, and not greater than 1, so it can be 1.1. So it's between -1 and 0. With 0 being no correlation, about -0.5 and +0.5. Let's make this bigger. All right, this from here to here is weak. Obviously, if you're negative, it's weak negative. If you're on positive, it's weak positive. And then the closer you are to 1 is going to be strong. So obviously, if you're here, it's strong negative, and over here is strong positive. If you're exactly at -1 or +1, it's called a perfect correlation. And of course, if you're negative, it'll be a perfect negative correlation. If you're on positive, it'll be a perfect positive correlation. All right, so now that I know that, that's what it looks like in numbers, which if I wanted to see the number, I could put in the scatter plot. So I could actually type this in. And in fact, I am going to do that because I'm going to show you what I think the answer is, and then I'm going to check it. All right, so I think the strongest positive, so this is negative, negative, this is positive, positive. All right, I think this is the strongest positive because all the dots are very close to the line. The further the dots are from the line, the weaker it is. I think this is the strongest positive. So if I wanted to prove that, I could type this in. So this is 2, 1, 2, 2, 3, 3. So I'm typing these dots in 4, 3, 4, 4, 4, 3, 4, 4. 5, 4, 6, 6. 5, 4, 6, 6. Obviously, this is taking a long time. However, I just want to show you, just in case the question changes, like you given a scatter plot and you have to find the correlation coefficient. So it's 7, 6, and 7, 7. All right, then I'm going to count how many dots I have. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I make sure I didn't miss anything. All right, to find out my so there's the dot plot, looks just like that. To find my strength, how strong this is, I click flag. This is my linear regression, my line of best fit. My R value, my correlation coefficient is 0.9647. And remember, we talked about the closer it is to 1, the stronger it is. So this is very close to 1, so this is very strong. If I put this in, which actually, why not? I'm going to do, because I'm going to actually teach you linear regression while I'm here. All right, so just keep listening because I'm actually using this to review something else. So 2, 3, 3, 2, 3, 3. And again, I'm putting in the points for 1, 5, 7, 6, 5, 7, 6, and 7, 7. All right, so this is this other one, which is weaker. Look at the dots, they look about the same. Just in case the question is, here's a scatter plot, find the correlation coefficient. So again, with zoom fit, we can see that it's positive. It should be weak, weaker, not weak, but weaker, which it is weaker because it's 0.80. So the 0.9 is the stronger one. Of course, please, 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 you should know how to determine the strength of the correlation coefficient from numbers as well as from graphs. Obviously, I don't want you typing it in if you don't need to. If they give you a question where they say, hey, determine the correlation coefficient of the scatter plot, then this is how you do it. All right, number 7. Lewis is looking at two rectangles with side lengths as algebraic expressions. The area of the first rectangle is x squared plus 6x. What could be the length and the width of the rectangle? All right, so they already told us what it is. So it's x squared plus 6x. But maybe in the other one, I'll see if they say another one. All right, so I'm going to hit home. All right, so they don't have an area. Look at two rectangles. The area of the first... Oh, they're saying this is the area. So what have they done to find area? They did base times height because it's a rectangle, correct? So they multiplied two things together to get this. So all I have to do is look at their answers, multiply them together, and if it matches this, then that's my area. So this time they're not giving me an area of a number, they're giving me expressions, which is fine. As long as you understand the area of a rectangle is found by base times height. So when I do area is this, I've done base times height. So if they tell me the base is x and the height is x plus 6, does that give me my area? It does. All right, I'm just going to do one more that's wrong just to show you that it wouldn't be. X squared plus 6x squared. You can see that is not my area. All right, so this is my base and my height. Obviously, now, which one? Technically, guys, these guys are wrong. Because technically, well, maybe x could be negative. There's no way x could be negative. Yeah, actually, these guys are wrong. This question is actually mathematically wrong. And let's talk about why. If I have my length and my width, my length should always be longer, right? So my length should be this longer one, and then my width should be the shorter one. And right now, they have my length as x and my width as x plus 6. So technically, this is mathematically wrong. So because that's mathematically wrong, I'm going to go see if there's anything else that matches just to make sure that they don't have, something in here. So let's do that. And 6x, that does not match. 2x times 3, that does not match. Okay, so this is the only one that matches, so this is right. Technically, this should be the length because I'm adding something onto something else, so it's going to be the bigger number. But we'll go with their answer. Technically, they're mathematically wrong. All right, number 7b. All right, there's a part B, so this is my base, this is my length. Look at triangles. Okay, two rectangles. Sorry, the area of the second rectangle is x squared. Okay, there's another rectangle, so the area of the second one is x squared plus 7x plus 12. All right, what is the sum of the areas? Okay, so what does this sum mean? it means I add. So what am I adding? I'm adding this area to this one. And I'm going to put parentheses to protect my order of operations in case we don't know our middle school math. I'm just going to add the two together. That's what I get. I'm going to hide everything else because I don't need this right now. What is the sum of the two areas? So this is the sum of the two areas. Obviously, that does not look like the answer. So all I have to do is put in the answer choice and see if it matches. So 7x plus 18 is our first one. All right, does that match? No. So we're going to do 2x squared plus 13x plus 12. Does that match? Yes, it does. So my correct answer is B. I'm just going to check everything else. Plus 25x is next. Does that match? Nope. 2x squared plus 7x plus 12. Does that match? No. So the only one that matches is B. All right. Now, since I'm here, let me talk about this area question. Usually we get the one that says something is less than 3 times the width. Now, remember we talked about the first number is going to be, the one that goes with x squared is going to be double if it's 2. Triple, 3, quadruple, 4, 5 times as much, 5. So the one that's multiplying, so double, triple, quadruple goes with the x. So let's do a double one. And then on the one, x squared, sorry, the one with the x is the one that goes with whether we are adding or subtracting. So if it says less, I'll put minus, less, let's say 2 less than, so I'll put minus 2. If it says maybe 3 more than, I put plus 3 with an x. And then area is always negative. So that if the area is 52, for example, then I put negative 52. Those are the questions we're used to seeing. And then I click on, okay, I made this question up, so obviously this is not right. But then you click on the positive one and then you get an answer. So let's say the answer is 4. Then you would put 4 back in to see into the words, right? To see which one is the second one. And then the longer one is the length, the shorter one is the width. All right. Number 8, ABC has triangles shown below. Okay, cool. What is the area of the triangle? All right, perfect. So you have to know, this is not on a formula sheet. The area is 1/2 base times height. So 1 divided by 2 times whatever the base is times the height. And we've talked about this before. With area, sometimes it becomes a whole number, sometimes it doesn't. I'm going to guess it does become a whole number, unless these are whole numbers when you put them in the calculator, which I know these are not perfect squares, so they're not. So I'm going to expect that it's either going to be B or D, but we're going to do it. So base and height. So we have to determine the L. So if I put right here, make an L here, is this going to be working? No. What if I do this one? If I make an L right here, does it match? No. If I make an L right here, does it match? Yes. So I found my L, which means if this is my L, this is my base, this is my height, or this is my base and this is my height. So I'm going AC. So with AC, and at this point, because we've done so much of this, I'm just going to type it in. If you need some help with doing this like a little bit slower, please just come see me or just watch our previous videos. So I'm going from A to C. So square root, let's start with our skeleton, squared plus squared, shift 6-2 with a minus sign inside. Now remember, this is the first time I've done distance, so I double check it with my distance formula. So let's check in our distance formula. Here's our distance. Parenthesis squared plus parenthesis squared with a minus inside. Yes, parenthesis squared plus parenthesis squared with a minus inside. All right, so this is my skeleton. We need it twice because I need the base and the height. I don't know why this is not making it longer. Okay, there we go. All right, so it's A, C, and then A, B. Okay, so from A to C, let's fill this out. 1, -3. Then keep the same order, 4, 0. All right, that's my first one. Then we're going to go from A to B. 1, 4, keep that same order, and then 4, 1. Boom, I knew it was going to be a whole number. 12 is our answer, okay? If this was not a whole number, then I would take this by itself, copy it down twice, all right? See what's under the square root, which is 32. And then I would start breaking 32 down and making it a perfect square. However, because this is not a perfect square, sorry, but simplest form. But because this is multiple choice, I could just type in the answer. So I would type in radical 72, see if it matches what we need. All right, so which situation could be modeled by a function with a domain of all positive integers? All right, you have to know what integers are. What are integers? 1, 2, 3, 4, 5, 6. Those are integers. Those are positive integers. Negative integers, -1, -2, -3, -4, -5, so forth. So positive integers, negative integers. All right, so if I'm looking for domain, is that my x or my y axis? All right, so you should say domain is my x-axis. So I'm looking for positive integers on my x-axis. So when I read all of this, I need to identify what is x and what is y. A distance, the distance a runner has moved during a race. So I'm running a race, and the distance I move as a function of time. So remember, we've talked about ninth grade function notation as a function of time, which means time is my x variable and distance is my y variable. So time is my x, distance is my y. So all I care about, my domain, is my time. And what I'm looking for is positive integers. All right, so if I'm looking at time, is that only going to be 1 second, 2 seconds, 3 seconds, 4 seconds? No, time doesn't jump that way, because I can have 1.1 second or 1.2 seconds or 1.0005 seconds. Time is continuous, it is not discrete. All right, so actually let me say what those words are. All right, so when you're looking at just, let me plot something for you. Let's say you had these numbers. Right, and I did a scatter plot by mistake, but it's okay. I'm gonna just do a linear regression. If I have dots like this, but they're not connected, that is discrete. If I have a line that connects every single dot, that is continuous. So when you have something that's discrete, it jumps 1, then 2, then 3, like that. But if you have continuous, it includes the decimals as well. So we're looking for something that does not have decimals because it's jumping 1, 2, 3, 4, 5, like that. So I can't have time because time can be written as a decimal. All right, the amount of fish food required in the fish tank. So I'm looking at food as a function of the number of fish. So the number of fish in the tank, okay, is my domain. So I guess I can just say number. All right, can I have 1.1 fishes? Gosh, that sounded so weird. But no, the answer is I cannot have 1.1 fishes. So that takes care of my decimal piece. So this one does not have decimals. I can only have 1, 2, 3. Now let me look at it on the other side, because maybe it's negative integers. Can I have -1 fish? No. Okay, so this one is positive integers. But I'm just going to go through the rest to make sure that we're right. The amount of power required to operate a computer as a function of time. Okay, so this is the same thing again. Function of time, I can have decimals, which means 1.1, not just 1, 2, 3, 4. So that's not it. The amount of water required by an animal as a function of mass. Okay, so function of mass, M for mass, so how much you weigh. Can you have decimals in weight? So I weigh 120, what do you guys do in America? I think not kilograms, pounds. 120 pounds. Can I have 120.5 pounds? Yes, I can weigh 125.5 pounds. So that makes it continuous because it's between the 1, 2, 3, 4, 5, 6, and 7, 8, 9, 10. All right, so this is not positive integers because I can have decimals. So the only one that it has to be is this one right here. All right, which situation could be modeled by the function with a domain? So again, we are still doing domain. So we're still looking at our x function that includes positive and negative real numbers. Okay, so let's go over a couple of definitions. We need positive and negative, and we need all real numbers. So all real numbers, remember, is capital R with 2 sticks on the R, I guess. I don't know how to write that. All right, so it's everything you can think of. So what they're saying is every number you could possibly think of is what I'm looking for my domain. Okay, so not just 1, 2, 3, 4, 5, but 1.5. Not just positive, but also negative 1.15. Shucks, I'm even looking for SQRT2, which is 1.4142. Can I have that? That's what I'm looking for in my words. All right, so let me read my words so I can see. The height of a plant as a function of time. So the height is the Y. Function of time is X. But when you think about time, can I have negative 1.1? No, absolutely not. So because I can't have negative 1.1, this is only positive real numbers. So time is positive real numbers. All right, the evaluation of a hiker as a function of the number of steps taken. So hiker, the elevation, sorry, not evaluation. The elevation, how high up the hiker is as a function of the number of steps taken. When I take steps, do I take 1.5 steps? No, but even if you're going to argue with me about taking 1.5 steps, we're looking for positive and negative. Can I take negative 1.1 steps? No, and please don't tell me you're walking backwards, because you're not. Walking backwards is not negative 1.1 steps. You're still taking one step just backwards, okay? So no, so this is not positive and negative real numbers. All right, the amount of time required to read a book as a function of the number of words in the book. All right, so let's talk about the words in the book. Can I have 1.5 words in a book? Absolutely not. What kind of book has 1.5 words? You have to fill in the blanks or something? Absolutely not. So I cannot have all real numbers in the book. The last one, the amount of participation as a function of the outdoor temperature. All right, so let's think about temperature. All right, so if it's 80 degrees or 80.5, can I have that? Yes. But if you go up north and it's the dead of winter, can I also have negative 3.4 degrees? Absolutely. So that's what I'm looking for. Positive and negative real numbers. All right, a company that produces strawberry, grape, and raspberry jam track the cost to make each type of jam each year. The cost to make a container of each type of jam increased, including supply costs. The cost in dollars to make the container of the strawberry jam and the grape jam are represented of the functions shown, where X represents the number of years since the company opened. So you have strawberry jam. What kind of equation is this? I'm hoping you said linear, because at this point we're that close to the EOC. What kind of equation is grape jam? I'm hoping you said quadratic, because there's a squared right there. The graph of the exponential function, so they're telling you this one is exponential, is shown on the coordinate grid that represents the cost in dollars to make the container of raspberry jam. All right, so now you're looking at all the functions that we've dealt with in class. So I'm just going to pull out the formula sheet real quick and just show you, should you forget what those functions are, that's okay. You go right into that formula sheet and see what they give you. So you can look at what linear looks like, y equals mx plus b. You can look at what quadratic looks like. There's three forms, but the form that they have it here is vertex. 1 parentheses is vertex, no parentheses with a squared is standard, and 2 parentheses is factored. And then, of course, exponential is right there. ABX to the power of X. All right, so now you know what the three equations look like. Let's go ahead and answer whatever this question says. Which statement is true about the cost to make the container of strawberry jam? So I'm only looking at strawberry jam, which is this linear one right here. All right, so I've got, and I'm just going to put it in decimal so I don't have to keep going back and forth. So I've got 3.10 plus 0.05x. All right, so let's see what this means. The cost to make the container. Okay, so even before I read all of this, I need to know, what do these words mean? So I've got y equals mx plus b for my linear function. What does m mean? And m is the one that's attached with x. What does m mean? Well, hopefully you just said my slope, the thing that keeps changing, right? So like every hour I pay $3. Every day I run 4 miles. Whatever is happening all the time, every something or per something. So you find the one with X, which is this one. And look at them trying to be slick, putting it second. It don't matter. You find the one that has the X. That's what you're looking at. So this is my per, or the thing that keeps changing. And then what is plus B? So you should have said y-intercept. Okay, so the y-intercept is the thing that happens one time, and then you keep applying the per, or the thing that keeps happening to it. So here's my y-intercept. Now that I know that, as a matter of fact, I'm just going to go ahead and say it right here so I don't lose it. So that's my B, and this is my M. Now I can read all this. So don't start reading until you identify, because you're going to get lost in your answer. So the cost to make the container of the strawberry jam was $3.10 in the year that it opened. So you're looking for my initial value. So what's my initial value? $3.10. So that's fine. The company opened and the cost increased by 0.05 each year. Is slope 0.05 each year? Yes, it is. So this is actually my answer. But I'm going to read through the rest of them to make sure. The cost to make the container of the strawberry jam was 0.05. No, that's how it's changing each time. It's not my original cost. So it's not that one. The cost to make the container of the strawberry jam was $3.10, yep, in the year that we opened, and then it increased by 5%. this is not an exponential function. If this was an exponential function, sure, it's increasing by 5%, but this is linear. So you're not multiplying, you're adding to it. So no. The cost to make a container of the strawberry jam was 0.05. Heck, it wasn't. It was 3.110. Don't let them tell you otherwise. All right, so that's the answer for that question. Second question, all right, what is G? So before I even go see the rest of this, which one is G? Grape jam. What does that look like? That one is your quadratic. All right, what does it represent in this situation? So again, before you start reading answer choices, I need you to understand what's happening in the problem. These people are making jam and they're increasing the amount of jam that they're making every single year. So that means before I start reading all these confusing words, I determine what that answer is before I do. So G of 4, and I don't remember if it's days, years, I can't even remember. Let's see, each year. Okay, so every year. So this is 4 years. So I'm just going to write that down right now. 4 years. Okay, so in 4 years, it's going to cost $3.04. Okay, the cost to make the container. Yeah, so the cost is going to be $3.04. So again, you determine your answer before you read your answer choices. So now I'm going to read my answer choices and see how they're going to try to confuse me. The cost to make the container of the grape jam in year 3. Who talk about year 3? We in year 4, so that's not it. The cost to make the container of the grape jam in year 4. Perfect. We're good so far. After the company opened was $3.04. That's exactly what I'm looking for. So I'm just going to read through everything else just to make sure. The cost of the container of the grape jam in year 3. Again, who's looking at year 3? We're looking at year 4. The cost to make a container of the grape jam in year 4, which is what we're looking for, of the company was opened was $4. So they just go change the cost just like that. But we decided what the cost was before we even looked at the answers so we don't get confused. Okay, so please get in the habit of doing that. So what we had there was the correct answer. All right, which function represents the cost in dollars to make the container of raspberry? Okay, so clearly this is strawberry, so we're not looking there. This one says grape, so we're not looking there. This one says the graph of the exponential function shown on the coordinate grid represents the cost in dollars to make the container of raspberry jam. So this is the one I'm looking for. Okay, I have a graph. Oh my gosh, what do I do to find an equation? Duh, we put the graph right in. And how do I put that in? I press plus and I put table. Okay, I got a table. What do I do now? Well, I need 2 points. Oh my gosh, look at them being so nice and giving you the points that you want to use. So 0, 2, don't type 0, 3, 1 and 2.4. I got my points in. Now, be careful. What kind of function was this? Because right now, even if I zoom fit, it's going to fit everything because there are only 2 points. Not enough information. But they told you that this one was which one? An exponential function. So we're going to click flag. And I don't even look at that linear and go right to exponential function. There is my exponential function equation. Now I'm going to go right to my answers and find that. So I should have 2. So I got 2 choices, A or C. And then I should have 1.2, which is that one. So it's growing by 1.2, not decaying by whatever that one is. All right. Now, alternatively, what you could have done, which will be so much longer, is type in all of these, hit table, and then match the coordinates, like go backwards. But that would have been too long. All right. Next question. Oh, one of the favorites. Okay. So we have a dot plot, and we want to put this dot plot into the calculator. What do we do? All right, so we're going to say we need to call it something. So let's call it A. And we're going to say that A is equal to close bracket. And we're going to put the plots in. So how many zeros do I have? Well, nothing. It's not there. How many ones? Nothing. It's not there. 2s, 3s, 4s. Nothing. It's not there. They're just putting these numbers there. How many 5s? I got 1, 2. So do I write 2 5s like this? Heck no. I write a 5, a comma, another 5. So I put in my 5s. How many 6s do you see? 2 of them. So 6, 6. How many 7s? Nothing. So I don't type 0 because it's not there. I type nothing. It's not there. All right. How many 8s do you see? I see 1. How many 9s? Nothing. How many 10s? I see 1. All right. And there's nothing else on there. I count 6 dots. Always, always, always double check. I should have 6 dots. 1, 2, 3, 4, 5, 6. Perfect. All right, so I got this data in the way I'm supposed to. Now let me read whatever this question is saying. Kendra and Theo each collected data on the number of birds they observed at the bird feeder each hour for 8 hours. The data Kendra collected are summarized as shown. The range of Kendra's data is 6. The median of her data is 7. The mean of her data is also 7. The data Theo collected have the same range and the same median. So for Theo, it should also be 6 and 7. And I know, even though this is a video, I know you did it, so that's fine. As the data Kendra collected, but the mean of Theo's data is 7.5. The line correctly shows 6 of the 8 data points for Theo's data set. So what it's saying is there's only 6 out of the 8, and that makes sense because I got 6. So there's 2 missing. Plot the remaining 2 data sets on the line plot. So you're going to plot them right here. All right, so let's go over a few things that we need. So we're talking about range, and how do you find range again? Range is the maximum minus the minimum. So the greatest value minus the smallest value. So how do I find that? I look at my numbers. The maximum is 10, or the upper extreme is 10, and the lower extreme, or the smallest value, is 5. So my range, if this was Theo's complete data set, would be 5. All right, the median was also the same thing. So we could click functions and just hit median, but you know I like it when you guys click stats because it gives us a whole bunch of them. And how do I do stats of what? Stats of this data set. So you got to tell the calculator, hey, go look at A and work out the stats for that. And it has. And then finally, I need the mean. So again, I go to a new line, hit functions, go to statistics and click mean. Again, mean of what? Mean of the data set A. So I've got all the information that I need here. I just need to manipulate what I have. Now, I'm going to start with the easiest ones because what I'm looking for is for it to be 6, 7, and 7.5. All right, so I'm looking for 6 right here, which right now it's not, and then a 7 right here, which right now it's not, and then a 7.5 is not. And for all of these, they need to go up, which means I need to be putting upper numbers. But I'll start with the range because the range, there's only 2 possible numbers it could be. So either, because 10 minus 5 is too small, I could have a 4 right here. So I'm just going to write a 4 because that will make my range, if this was a 4, the smallest number, it would make it 6. So I could have a 4, or I could have an 11 because I now change my maximum from 10 to 11. And that will make my range a 6. So I have 2 numbers that I could try. Now, remember what I said. If you know your 6th grade math, this is just interpreting what that means. So when I look at this data, which one am I going to pull? Well, I should have my median needs to be bigger. My mean needs to be bigger. I'm not starting with a smaller number. I'm just going to be guessing for a long time, and that's not going to work. So I'm going to start with 11. All right, let's look at where we are now. So that gives me my range of 6, which works. Now my median is 6. So my middle number, so if you think of a seesaw, right? And the middle of that seesaw is where the balance happens. And if you have equal weight on both sides, it's completely straight. But if one side is heavier, then it's not straight. Well, if my median is the middle of that seesaw, it's what's balancing everything. And I want it to go higher. Would I put my number on the left or on the right? Well, I'm hoping you said on the right because I want this median to go up. So I'm going to put it on the right of 7. So whatever number I guess is going to be right of 7. And then at the same time, I'm looking to see if this is going to be 7.5. So let's try 7. Okay. Did that change my median? It did. It put it up 6.5, but that's not enough. It didn't change it enough. So let's try 8. All right, again, that put me where I needed to be. So right now my middle is 7. That's exactly what I'm looking for. But the last thing is my average also needs to be up. So 8 does not work. I'm going to try 9. 9 is perfect. Now I have my middle number is 7, my range is 6, and my mean is 7.5. So my 2 numbers that I needed to add to my data set are going to be 9, which I just plot right there, and 11, which I plot right there. Okay, so this is the complete data set, 2, 4, 6, 8. Pieces of data. All right, so the last question, it says the graph of the linear function is shown below. What is the value that represents the y-intercept of f of x? So I'm just looking for the y-intercept. Do I need to go ahead and type it in? I do not, okay, because I can see what the y-intercept is. So mathematically, I think the y-intercept is 0, 4, because that's where it happens. So I'm going to go parentheses. Oh, wait, it's not typing parentheses. You hear how hard I'm hitting the key. It ain't going to magically make it come up. So use your brain and stop hitting parentheses And what else can I hit if I can't put parentheses 0, 4? If I only can put numbers, a negative or a fraction, what else can I put in for this right here? 4. Now, there's no possible way that I know exactly what they're going to ask you. So at this point, you need to also stop for a second and just think. No one is going to be able to tell you, oh, okay, don't use the parentheses, use something else. No one's going to tell you that. So again, take a moment, pause, just reflect and think. And if the answer doesn't come to you, just come back to the question. It's going to be all right. Let's practice.